Let ABCDE be a convex pentagon with AB equals 14, BC equals 7, CD equals 24, D equals 13, EA equals 26, and angles at B and E are 60 degrees. For each point X in the plane, define Fx to be the sum of the distance from this point to the vertices of this pentagon. The least possible value of X can be expressed as m plus n root P, where m and n are positive integers, and P is not divisible by any square of prime. Find m plus n plus P. Right, so the figure looks like this. And then these are the side lengths. And let's first observe that when we draw DA and CA, due to this side lengths and the angles, we have two 30, 60, 90 triangles. Then these sides are 13 root 3, and then this is 7 root 3, right? And next, the condition in the problem is a little too difficult to figure out. Like we just measure the distance from the point to all 5 vertices, right? But now what we can do is we can try maybe minimizing the distance to 3 of them or 4 of them, 3 of them. So what we know about the triangle is that we know that the Fermat point is the minimizer. So in any triangle, the point whose distance from this point to the vertices of a triangle is minimized when this point is a Fermat point, and then the Fermat point satisfies that these angles are 120 degrees, right? And then now, if we are very lucky, extremely lucky, we just maybe choose one Fermat, like pick the Fermat point of a triangle, possibly like this triangle, and then cross our fingers and hope that this Fermat point also minimizes the distance from this point to E and this point to B. And in order that to happen, this point needs to be on the line BE, because the sum of those two distances is always at least BE, greater than or equal to BE from triangle inequality. Now, we are too lucky in this case because we can prove that this Fermat's point is indeed on the line BE, hence that's the point that minimizes the sum of the distances, and then we just work with this point. But first, let's show that this is indeed true. So if this point is the Fermat point, let's call it X. So now this angle is 120. This angle is 120. First, observe that those 4 points make vertices of cyclic quadrilateral because two opposite angles add to 180, right? So hence there's a circle passing goes through 4 points. Similarly, observe that those 4 points are vertices of a cyclic quadrilateral as two opposite angles add to 180. Hence there's another circle passing through those 4 points. And then now we can just draw this side and then do an angle chase. Observe that okay, observe that this arc is seen by 90-degree angle here. So this angle is 90 degrees. Moreover, this arc is seen by a 90-degree angle. So this, right, if we just draw this line, this is also 90 degree, right? Observe that this is a straight line as those two angles add to 180. Hence, X, the point X, the Fermat point, also on line BE, and it minimizes the sum of the distance from X to the vertices, right? Now let's work with X, but first I'm going to erase this stuff. I'm going to draw it so that the point is on actually on the line, okay? So let X be somewhere here. And now what is the next thing that we can do? So this is 30 degrees, 30 degrees. We need to figure out BE, right? So BE, and then also AX plus BX plus CX. Okay, I'm going to do it separately. So first, let's start with BE. So in order to do it, first I'm going to find this angle, or actually the cosine of this angle. Let me call this angle alpha. So what's cosine alpha? I can just find cosine alpha using this triangle and inverse law of cosine's theorem. So this cosine alpha is indeed 13 squared times 3 plus 7 squared times 3 minus 24 squared all over 2 times 13 root 3 times 7 root 3. And doing the algebra, I get cos alpha is 1 over 7. And then next, I would like to find cosine 60 plus alpha. So let's find cosine 60 plus alpha. So this is cos 60 cos alpha minus sine 60 sine alpha. So this is 1 over 2, 1 over 7 minus 40 root 3 over 2 times 4 root 3 over 7. So this is negative 11 over 7. Okay, and then now finally, let's use law of cosines on this triangle and obtain BE, right? So let's do it here. So BE squared equals 26 squared plus 14 squared. Oops. Now in this case, it's going to be plus 2 times 26, 14 times 11 over 7. And then this is indeed doing the algebra. We obtain this equals 38 squared, hence B equals 38. Okay, so this is the first part. Secondly, we would like to find AX plus BX plus CX. How about if I just kind of erase this part, and then now I know that alpha, cosine alpha is 1 over 7. So dropping this perpendicular, this is 7. So in this triangle, this is root 3 because of trigonometry, leaving a 12 root 3 here. So we are using cosine alpha equals 1 over 7. And then just observe that in this triangle, like this triangle is a special triangle, right? So this angle has to be 60 degrees, and this angle is 30 degrees, right? And then now, this is nice because it is going to help us to figure out the quantity that we want to find, which is AX plus BX plus CX. But first, let me just erase certain parts so that I have more like space and more clear figure. Okay, next, here comes a standard trick. How about if we draw an equilateral triangle outside here, and then observe that those 4 points are on the same circle. This, because of the two opposite angles at 180. So this is 61, 20. So they add 180. And then when we apply, first let me just draw this circle. When we apply the Ptolemy's theorem here, okay, the Ptolemy's theorem, we immediately get 24 times, this is CX, 24 CX, plus 24 times DX, 24 DX, equals 24 times, let's call this T. So this 24 times T. And this T is indeed CX plus DX, okay? And then when we expand this is AX. Okay, actually, this is like a consequence of not Ptolemy's, but Fermat's point that this is a line, right? And then we can just figure out AX plus, no, actually, CX, BX, DX plus CX plus AX by figuring out this length here. And then for that length, I can use this triangle here. Now, why am I using this triangle? It's because this triangle is a special triangle due to this 30 degree angle here and the 60 degree angle here makes this angle 90 degrees. Hence, we can use Pythagorean theorem to obtain that, or actually I didn't write it correctly, so this has to be indeed AX plus CX plus DX. Okay, so hence AX plus, let me just work it here. So AX plus CX plus DX is indeed square root of, from Pythagorean theorem, so this 24 squared plus 3 times 13 squared. And working the algebra, we obtain that this is 19 root 3. Hence, combining these results, this and this, we obtain that f of x is at least 38 plus 19 root 3. And these are the numbers that we want, right? So our answer is the sum of these numbers. Now let's write the final answer here. So this 38 plus 19 plus 3 is 60, and 60 this is our final answer. Okay, so 60.